So, nakikita natin sa image na to kung paano nga ba nakaka-apekto yung coral bleaching sa mga corals. Siyempre, yung unang nangyayari, makaka-apektuhan ng mga zooxanthellae. Yung zooxanthellae yung nakakandang ng photosynthetic process sa mga corals. So, yung healthy coral, zooxanthellae, and coral tissue, pag na-apektuhan siya ng different process, nabibig siya at may expel sa tissue ng mga coral reefs. Ang mangyayari, mamamatay ng mga coral reefs dahil sila nga yung tumutulong sa mga coral reefs para mag-produce ng mga carbonates galing sa tropics. Next slide, please. Dito naman sa image na to, nakikita natin kung gano'ng kalawak naganap ng coral bleaching sa Great Barrier Reef sa Australia. So, what are the common causes kung bakit nga ba nagaganap yung coral bleaching? Number one is increase or reduce water temperature. So, climate change. So, yung mataas na temperatura ng tubig at matinding sikat ng araw yung cause thermal stress in corals na makakain ng resulta sa pagkasira ng normal photosynthetic process ng mga coral zooxanthellae. Next is bacterial infection. Meron bacteria na umaatake sa mga zooxanthellae at tinatawag na ito Vibrio spelling, V-I-B-R-I-O, S-I-S-H-I-L-Y. So yun, yung mga bacteria nito is very infectious during warm season. Next is increased solar radiance, photosynthetically active violet lights. So yung sinasabi dito na during summer, mas marami yung nagaganap na coral bleaching. Siyempre, nataas ang temperatura gaya naman sinabi ko kanina and solar radiance. Lubos na na-apekto ng mga nakatala sa mababaw na area ng coral reefs. Next is changes in water chemistry. Kapag mataas ang ocean acidification, ibig sabihin lang natin mataas din ang carbon dioxide. Alam naman natin ang carbon dioxide, iniipon niya yung init at nagkakos ito ng nag-trigger ito para mapalala yung bleaching effects dahil na rin sa thermal stress. And last is low tide exposure. So, low tide exposure, may mga kakataong na-expose to the atmosphere ang mga reef during extreme low tide. Related sea level drop or tectonic activity can potentially induce bleaching. So, yun yung all about coral bleaching and coral reefs. Next report will be Miss Training.
Going to report about the mangrove swamps. Bali sa Tagalog ng mangrove swamps, Bakawan. Mangrove swamps replacing salt marshes on tidal floods in tropical regions, also called mangrove. The plant community of a mangrove swamp is most commonly termed mangrove or also known as mangrove swamp, forest, or mangrove. It is a forest with a dense canopy, and the canopy means is the outer layer of the leaves. Mangrove occurs more than 2/3 of all saltwater tropical coastlines parallel to the shoreline. This is a very narrow ridging forest, and hence less than 1/10 of the Earth's surface is inhabited by mangrove. Coastal wetlands found in tropical and subtropical regions. These wetlands are often found in estuaries where fresh water meets the salt water, and it is characterized by halophytic trees, shrubs, and other plants growing in brackish to saline tidal waters. These halophytic trees are also called salt-loving trees. The other characteristics of mangrove swamps are contorted hardwoods with unusual root systems growing in swampy tidal plants. So I'm going to discuss about the three kinds of mangrove swamps, which are the black mangrove. Black mangrove. These black mangrove these are the common mangrove found in the United States. Black mangroves have thin or pencil-like or straw-like roots tubes that grow out of the ground around the base of the tree. These cable roots or root projections are also that act as a breathing tube underground system. So, red mangrove. These red mangrove are easily recognized by its distinctive arching roots. As you can see, they have long crop roots that grow out of the trunk and those drop roots that grow out of the branches. These extra roots reach down to the ground and provide support to the trees while bringing in more oxygen. And these are the white mangroves. White mangroves often grow even farther in inland with no outstanding root structures. At high tide, both red and black mangroves are standing in brackish water and serving as refuge for many tiny marine creatures. Other characteristics. Mangrove trees are characterized by shallow, widely spreading roots or by crop roots coming from the top. The mangrove's massive root systems are efficient at dissipating wave energy. So I'm going to discuss about the adaptation of the mangrove swamps. Not many plants can make it in Mangal. Only about 100 plant species are found in most mangrove swamps. Some swamps are home to only 1 or 2 species. Mangrove swamp has the ability to survive in both salt and fresh water. Bali yung sinabi ko kanina, yung halophytic or also called salt-loving trees, the leaves, although tough, are often succulent and may have salt gland. Mangroves can limit the amount of water they lose through their leaf. Adaptation. Inundated area. Red mangroves, which can survive in the most inundated areas, prop themselves above the water level with still roots and can then absorb air through pores in their bark or also called lenticels. Black mangroves live on higher ground and make many nematophores, specialized root-like structures which stick up out of the soil like straws for breathing, which are also covered in lenticels. The plants that do survive have breaks up their sleeves called adaptation to deal with the special challenges. Bali, yung red mangroves, may tricks sila kung bakit sila nakaka-survive sa mangrove swamps. Though, yung water sa mangrove swamp ay very salty na it can almost kill all the plants. Ang trick ng red mangrove swamp, they contain a waxy substance that helps keep salt out. And the salt that get through this barrier is sent to all leaves that the trees then share. Tapos, ang trick naman sa white mangrove swamps kung bakit sila nakaka-survive ay they have glands in their leaves that let salt pass from the inside of the tree to the outside. The leaf becomes speckled with white salt crystals, which is how they got their name. Salinity. Mangrove swamp are halophytes. Halophyte means plants that are adapted to saline soils. The most salt-resistant species also tend to show avoidance to salt stress. Avoidance can be achieved by excretion of crystalline salt from glands or hairs of leaves. Nutrient uptake. The biggest problem mangroves face is nutrient uptake because the soil is perpetually waterlogged. Little free oxygen is available. Nematophores or aerial roots allow mangroves to absorb gases directly from the atmosphere and other nutrients such as iron from the inhospitable soil. Mangroves store gases directly inside the roots, processing them even when the roots are submerged during high tide. So, additional dun sa adaptation, mangrove plants have salt resistance. These may involve cytoplasmic tolerance of high solute concentrations, and many of the common species have in leaves sodium, and chloride ion levels that each exceed 250 millimoles, about half that of seawater. And another one, mangroves are salt resistant. They have adapted the ability to live within the salt and the fresh water. However, may be some instances na they cannot survive with excessive amounts of salt within them. So the trees have developed ways to exclude the salt